Welcome back, Math 2. Today we're just going to get a little bit into scientific notation. Those of you in chemistry have probably been dealing with scientific notation for a good week or two right now. We are not going to get that in depth, but we are going to mostly learn how to switch between scientific and standard form. Okay, so for those of you not in chemistry yet, scientific form, or actually, let's start with standard form. Okay, so standard form is just when you have a very large number, maybe like that, and it's just very, very long, something like that. It can also be very, very small, as in a decimal with lots and lots of zeros, something like that. These are all in standard form. Okay, and scientific form takes that and makes it a little smaller. So let's say, so they would have something like 2.58, and they always have that times 10 to some exponent, or 1.39 times 10. They can have negative exponents as well. Okay. Okay. So you might be asking, well, what's the point? I can just write out the number. Why would I bother having scientific notation? Okay. Well, first off, this is for very large numbers that take up a lot of space. Okay. Because writing this is going to be a lot shorter than having to write out this huge number, especially if in like a lab report or something, you have to write the number multiple times, or it comes out a lot multiple times. A lot of scientists, mostly when they deal with some very large or very small numbers, and it's simpler to have this scientific notation that cuts down. Okay, so let's actually, I know it says scientific to standard practice first. Let's actually do standard to scientific. So I am just going to make up a number 3758 with a bunch of zeros. Okay. So I have what is this? Hundreds, thousands, millions. Yeah, okay, so this is 3,758,000,000. That's a huge number. Okay. Right now, all that we really do in scientific notation is move the decimal to a better place. So right now, the decimal is here. We don't bother to write it, but where we want it to be is right here. We want one number in front of the decimal. So I'm going to write that. And then I'm going to put any significant numbers, basically any numbers that aren't zero, after it. Now, if there was a zero in between, like let's say it was 3058, that would be a zero I include, because it's going to lead me to some other significant numbers. Okay? Let me erase that real quick. Okay. So that part is pretty straightforward. You want the decimal to be behind the significant number, and then we're going to put times 10. Now we have to determine the exponent, and the exponent is determined by how many times did we have to move the decimal to get there. So here's what I mean. I have to move it once, 2, 3, 4, 5, 6, 7, 8, 9. I had to move it 9 times. So this is going to be 3.758 times 10 to the 9th power. And this is scientific notation. Okay. Now, positive exponents mean that the number is very large. So that's another way you can just tell by looking at it. Oh, this has all the zeros after the 8. Sometimes you also have really small numbers. So let's say we have 0.0000302. Okay. Again, we want the decimal behind. We want this to go, let's undo that. We want the decimal to go right here. So I should have 3.02, okay, times 10. Now, because this is a decimal, a very small number, this will be a negative exponent because I had to move the decimal backwards. I'm moving it to the left. Okay, so I'm going to count 1, 2, 3, 4, 5, 6 times I had to move it. So 10 to the negative 6. Okay. So those are pretty straightforward. If you have a really large number, you have a positive exponent. If you have a small number, you have a negative exponent. Okay. Let's go back up to the other way around, switching from scientific to standard. Okay. So let's say I started with 2.091 times 10 to the 7th. Okay, this is a 7. Sorry, it's a very terrible 7. Ugh, I don't like it. 10 to the 7th. Okay. What that means is because it's a positive exponent, I'm going to be moving the decimal this direction 7 times. Okay. So some people like to rewrite it out. Okay. And I'm going to show you what it looks like. So I'm going to move it 1, 2, 3, and now I have 4 more spaces to move it. 4, 5, 6, 7. All of these spaces will get filled with zeros. So I'm going to rewrite this number as 2091 with 4 zeros. And now I can put my commas in. Okay. It works the other way too. Let's say I had 5.3 times 10 to the negative 4. Okay, a negative exponent means I'm moving the decimal to the left 4 times. Okay, so I'm going to have 5.3, and I'm going to move it 1, 2, 3, 4. Here's my new decimal. And again, I have to have zeros in those blank spaces. And because this is a decimal, I'm going to have a 0 in front of the decimal as well. So 3 decimal places, 5, 3. Okay. So most of this, again, is just moving decimal places around. It's not really, we're not going to get really any fancier than that. Okay. So that is scientific notation.